Hello, folks. My name is Mike Bursell, and I am the Executive Director of the Confidential Computing Consortium. Tina, thank you very much indeed for setting us off. As you say, we've got a lot of people, many more prestigious than me, including our very next speaker, who I'll introduce at the end of my talk, to tell you about where pets live in this ecosystem, some of the ways that they can help us solve problems, and what the opportunities are. As the head of the Confidential Computing Consortium, I'm going to be focusing a little bit on confidential computing, but not solely. So let's start off with our first slide, please. So the first question really is, what is confidential computing? Given that that's my specialist topic, that's where we're going to start. So let's start with a definition. Next slide. So can we go back one? Oops. Confidential computing is the protection of data in use by performing computation in an attested, hardware-based, trusted execution environment. That's a bit of a mouthful. So what does that actually mean? Well, the first thing is, what are we talking about when we're doing protection? On the right-hand side of the screen, you'll see a white sort of square. I think of computers this way. If you think of a system, a cloud system, or a system on a data center, you've got the white bit is the machine itself, and then you've got some workloads, some applications which are running on that system. And typically in a virtualized scenario like the cloud, whether it's containers or VMs or whatever, you might have workloads from different people. And there's a concern that those the data in those workloads and the applications itself can be attacked, can be compromised either by another workload, or in fact by the host operating system itself, someone who's got access to the host operating system. And so what we're looking to do is protect the data in use in that workload by using confidential computing. Next slide, please. So no, back to slide 4, please. Thank you. So it's the protection of the data in use which is the important bit here, because when typically we talked about encryption and protecting data before, we've generally talked about protecting it when it's on the network, so that's in transit, or in storage on a disk, in a database, something like that. But being able to protect it in use when the data is actually in RAM is really important, and it's something that pets are all about. So there's something different specifically, however, about confidential computing. Slide 5, please. And that is that it is using hardware-based technology. So confidential computing is based in the chips, in the CPUs, the GPUs, and maybe in the future DPUs or NPUs, which are providing chip-level capabilities which are protecting your workload, protecting that data in use while it is being computed on, while it's being executed. There's more detail we could go into, but I'm not going to do that now. So that's the very basic thing. We are protecting your data in use, and that's pretty much the same for all pets. The difference here is how we do it in confidential computing, and that's with chip-based technologies. Slide 6, please. So what are some key features about confidential computing, CC? Well, the first, as I said, is it's hardware-based. The next thing is that as well as the confidentiality of the data, it actually gives you assurances about the integrity of that data. Not only can people not look in, but they also can't change it. But the same also goes for the code that's actually acting on that data. So the integrity of that is also protected, and optionally the confidentiality. So you can actually you can protect the what that application is, so no one can see it. Not even the person who owns or runs or operates the system on which it's running, even if they have access to the hardware, even if they have access to administrative or kernel or hypervisor level capabilities. Another thing which is important is attestation, because confidentiality and integrity, you need to be able to trust that that's happened. And attestation is a mechanism, remote attestation is a mechanism by which you get a cryptographic assurance that what you think is running and what data you think is being acted on is what you think it is. And so that allows you to build a whole bunch of new capabilities around what you're doing with confidential computing. And last but not least, it's near native performance. Because it's a hardware-based capability, you're not slowed down by sort of complex calculations or other issues, which is not the same for all pets. And one of the things that we're going to be talking about today, I suspect, is some of the differences between different pets, different PETs. Next slide, please. So how does confidential computing relate to pets? So first of all, confidential computing is itself a pet. It is part of the family of PETs. And the confidentiality is, of course, a key feature that we're talking about. Confidential computing is a bit of a giveaway. Next slide, please. Slide 8. But it's complementary with other pets. So, for instance, you might run other privacy enhancing technologies within a TEE. You might say, defense in depth, or giving the adding the different capabilities that particular pets are strongest in together makes a lot of sense. So because it's a hardware based and you can run pretty much anything in a TEE, a trusted execution environment, that allows you to do that. Also, there are times, of course, when the machine or the component you're running things on doesn't have a trusted execution environment. Maybe the chip doesn't have that capability. And so other parts of the system may require you to run other pets, which makes a whole bunch of sense. Also, there are times when you want to have cryptographic assurances which are stronger or different to those that the hardware itself can provide. And that is another very good time when you might want to say, well, I want to add this to confidential computing or use it separately. Next slide, please. But also, there are times when you might want to add confidential computing to your existing use of pets. So attestation is one of those examples. I talked about how attestation can give you cryptographic assurances that what you think is running is in fact running. And so this can be a really useful thing to add to your system. Another thing is, of course, that not all PETs provide you with integrity assurances. Confidentiality is pretty common across PETs. That's kind of the point of many of them, because privacy requires confidentiality in almost all cases. But integrity is something which not all PETs can provide, and confidential computing is very useful for that. And the other thing, of course, is, as I said, some PETs are slower. They have different optimizations. But if you are looking for high performance, then for some or all of your process, then using confidential computing may make a lot of sense in that context. So, confidential computing is itself a PET, but it's absolutely complementary with other PETs. And at the Confidential Computing Consortium, that's been our view right from the beginning. Let's go on to the next slide, in fact, because it is time to talk a little bit about the Confidential Computing Consortium. And slide 11, please. What is it? So we have another definition. The Confidential Computing Consortium is a community, first of all. We're a community of lots of people from across the world focused on projects, and that's open source projects specifically, about securing data in use and, of course, accelerating the adoption of confidential computing through open collaboration. So we do a number of different things. We are part of the Linux Foundation, and so open source is very important to us, but open collaboration is equally important to us. We do a lot of technical work, and it's a great opportunity for companies which may be competing out in the marketplace to work together on technical issues like getting particular capabilities into the Linux kernel, for instance. We do outreach and marketing, speaking at events, doing webinars. And if there's resources you want to find out more about open source and in confidential computing or confidential computing in general, we have white papers and videos and a whole bunch of different things to do that. We also try to encourage the ecosystem. We've seen some very good growth over the last 2 or 3 years, and also talking to regulators and working on standards, because if we want PETs to be adopted, whether that's confidential computing or other PETs, we need to be talking to the regulator or the regulators around the world and standards, and getting these PETs embedded in new standards and new regulations. Next slide, please. So this is a little thing about some of our open source projects. All of our projects are open source. They are in various languages across various platforms. So there are implementations of TEs across multiple architectures, not just Intel, AMD, NVIDIA. There's some capabilities from IBM, from RISC, from ARM. And so our projects are across those, some on a single platform, some on multi-platform. We've got 14 currently. I've got at least one, if not 2 or 3 more who are looking to join. And we help these open source projects with their community and provide a home. And so it's a great place if you're looking to get involved in confidential computing to get involved. And we have a bunch of different types of projects across the stack. Some of it's attestation, some of it's making it easy to use with AI or to use in a particular language. Come and find out more about our projects. We'd love to tell you more about them. Next slide, please. I hope you've got lots of questions. I'm going to be leaving time for some at the end, but for now, I'll carry on. So in terms of members, we have 4 different types of member. We have premier members, people like Intel and NVIDIA and Google are all premier members, and they get a seat on the governing board and voting rights across the various committees. We have general, and they're represented on the governing board by elected members, and we have startups. It's membership of the CCC is free for the first year for a startup with under 100 employees, but also associates. So if you're a non-profit or academic research body or government department or anything, and you're interested in getting involved with the work we do, then please join as an associate. That's very easily done. Next slide, please. So the ecosystem is made up of lots of different parts. And this is one of the interesting things about confidential computing. Right at the top, you've got end users who are actually going to be using this tech, whether this is banks or their customers. Then you have SaaS providers and ISVs. You have the hyperscalers and the cloud service providers. But also below that, you've got operating system vendors, OEMs, the Dells, the HPs and folks. And then you've got the silicon manufacturers and vendors or designers and vendors. And all of these parts fit together. And we hope to work with all parts of these as our members. Next, please. And the other thing, of course, is that like all pets, confidential computing is appropriate and used across lots of different types of use case and sectors. So if you can't see your sector there, I can pretty much guarantee that confidential computing is being thought about or used in that sector, and we'd love to talk to you about how that works. Next slide. So just to round off, a little bit about the Confidential Computing Consortium and the PET initiative. We're here to get our heads around the PET initiative. Next slide. What does that mean? So to be clear, the CCC has always seen confidential computing as part of a larger landscape of pets. It doesn't sit on its own. Next slide. So this picture is one which is taken from one of our white papers, originally created, I think, in 2019, 2020. Even then, although we didn't name all of them, we've got two different pets at the top. We've got homomorphic encryption and a multi-party computation. I hope we're going to hear more about those over the next couple of hours. But we absolutely see ourselves as part of that landscape. And so for us at the Confidential Computing Consortium, this is an opportunity to work with other parts of the ecosystem, of the broader pet ecosystem, and understand what opportunities there are to work together, what's best practice, when should you be using different PETs in different ways, how are regulations appropriate or different, or standards appropriate and different for different PETs in different use cases. Next slide, please. This is not the first time we've heard about it. Tina presented to our governing board fairly recently, and a number of organizations and individuals are already involved in both the CCC and the PET initiative. So, as I said, absolutely complementary. Next slide. So we look forward to working with the PET initiative, and some of the things we hope to be working on is possible collaborative research, best practice for combining PETs, use cases. How are they being used? How can they work together in those cases? And how can we expand our use cases in the ecosystem to understand what's going on? There's opportunities for exhibitions and conferences. And of course, we have these 14 different open source projects. And I really hope that, several of them will end up being used within the PET initiative to be doing things. And I fully expect there to be joint meetings as well as we go forward. So that's my last slide. Last one is, I think, asking for questions. If you want any more information, please do visit confidentialcomputing.io. And if you can't find the information there, get in touch with us. There's email addresses to do that.